Hey viewers, welcome to this video on NS3. In previous video, we have discussed about the custom applications and its simulations in NS3 with an example. So, if you are new to this video, then I might suggest you to watch our previous videos, and for your help, I may have pinned the link of the playlist in the last video in the description box. And yeah, consider subscribing to my channel for more such videos. So, without wasting much time, let's get started with our today's video. In today's video, we'll be looking at one example of utilizing the trace source and custom applications combinedly to generate the graph of time versus window size to understand the behavior of various TCP variants. So, we'll be walking through the fifth.cc file in this video, and without wasting much time, let's get started. So, we'll be looking at the fifth.cc file. Before we actually look into the fifth.cc file, it is important to look at the whole scenario. So, let's say we want to learn the behavior of various TCP variants, and for that we obviously need to collect the data or sizes of congestion window at particular time. And if somehow we can populate the graph of time versus the size of congestion window, then we can compare the various algorithms by looking at the graph, right? And for that we obviously need to collect the data for the changes in the congestion window. So let's say we want to look out for the trace sources that gives the information about the changes in the congestion window. So the first step is to look out for the trace sources. That are there such trace sources available? So the first thing that what you will do is to consult the list of all trace sources that we can find over here inside any web browser. If you can open the all trace sources from the NS3, then you will find the list of all trace sources, and from there you can find the word congestion window. And so there are exactly 4 matches. So let's look out for all 4 matches. So this is not the thing, this is not the thing. Yeah. So if you look at this file, or not this file, this is NS3 : TCP socket base. So there is a congestion window trace source available. It says the TCP connections congestion window. So yes, by doing this you found out that there is a trace source that is available for the congestion window. Now so you found out this from the Doxygen, and if you scroll the things, then you will not find any more what you can say, the results that are helpful. So this is the first way. Now if you just look out for this folder structure inside the source, so most of the TCP implementations are inside internet model, and if you just search out for TCP, you will find hell lot of files. See, these are all the TCP implementations. So you can also do this by command, by the help of command. Let's say you want to find the what you can say, the files which are having extension of .cc, and inside those files you want to find the reference of TCP. So you can use this command, find command, which is very helpful, and it will populate the list of all lines, all files, and in all files it will give you the lines which are having the word TCP in it. So you can look out for this, and you just need to focus on internet. This is src and then internet directory. Okay, and now if you have found out from over here that the congestion window trace source is available, so you can directly use the find command to find the word congestion window. And as this is an ignore case from this option -i, you don't need to worry about the case sensitivity. So now you just focus over here, socket base. What we can see, so inside source folder there is the internet, so there are lots of files, and you can see this line, add trace sources. Remember this line that we have observed previously for adding the basic trace sources that we have seen in our previous videos. So the first step is to open this file, which is model, inside model TCP socket state. So if you go over here and find TCP socket, okay, so these are two files, and actually I have opened those files inside gedit. This is not base, let's open it. Okay, so inside .cc file, these are trace sources, and from that trace sources let's just find. Okay, so there is no such thing congestion window. Okay, so this is trace source congestion window, and it is saying that it is a TCP connections congestion window, and you need to refer this variable. So let's copy this variable name. Inside this .h file we can find that variable, and you can see, so brief callback pointer for CWND trace chain, and it is having uint 32, uint 32. So this is the signature that you need to look out for. So these are the steps that I have followed to find the reference for the trace source congestion window. So we have tracked down that we want to observe the changes in the congestion window, and I have showed you the step-by-step procedure to, what you can say, find the trace sources, the signature of the trace sources, and there are several ways that we have seen using the find command and lots of other things, and actually observing over here. So that you need to follow. So by observing these things, this should tell you that you now understand this code completely. If you map with the previous videos, then you can have idea that if we have the pointer to this TCP socket base, which is having the trace sources for this congestion window, then we can trace connect to the congestion window, and if we provide an appropriate callback target, this is the same kind of trace source that we have shown, or that we have seen in simple example at the trace source section of our previous videos. So we now know that we need to provide callback that returns void and takes two uint 32 parameters. So the first being the old value and the second being the new value. So this is actually the signature of the trace source. So that's the thing that you need to understand over here. So you now understand the way that how we have tracked down the trace source. So now it's always best to try the find out working code rather than trying to what we can say starting from the scratch. So you can find the, what we can say, the working code that is laying around that you can modify. So the first order of business that now is to find out some code that is already hooked the congestion window trace source and see if we can modify it. As usual, the find command and the grep commands are your friends. You can find this command again, and yeah, you don't go inside this examples directory. This is my directory that I have created. You don't have these results in your what you can say files. And yeah, these are some interesting things. Config connect with out context, and this is the thing. See, so now we can open this file, which is inside test NS3 TCP, and there is NS3 TCP loss test. Okay, let me go again, test and NS3 TCP. Okay, so src, then test, then NS3 TCP, then it is NS3 TCP loss. Now we can open this file to view that how the trace source has been hooked. Now let's just find out congestion window. Yeah, so there is this file, there is this line actually which is saying okay, we can look out for this function also. Okay, see, the signature is exactly the same as they have mentioned over here. This is the actual signature and this is a test file. Okay, so now actually before we move to the fifth.cc file, there is one major thing that, or we can say there is one problem that we need to address over here. So the fifth.cc file is an example demonstrated an extremely important rule that you must understand before using any kind of attribute. You must need to ensure that the target of the config command should exist before trying to use it. So this is no different than saying that an object must be instantiated before you try to call it. So in particular, NS3 socket is a dynamic object often created by the applications to communicate between nodes. So an NS3 application always has a start time, stop time associated with it. In vast majority of the cases, an application will not attempt to create dynamic objects until its start application method is called at the start time. This is to ensure that the simulation is completely configured before the app tries to do anything. So the answer to this issue is that we can create a simulator event that is run after a dynamic object is created and hook the trace when the event is executed. And the second is to create the dynamic object at configuration time, hook it then, and give the object to the system to the what we can say use during the simulation time. So we took the second approach inside the fifth.cc example. So now let's walk through the first fifth.cc file, actually not first.cc file. So let's me open the scratch, it's inside examples, tutorials, and there is this fifth.cc file. So actually there is this what you can say copyright notice, then there are several includes, and there is this demonstration, and the same problem that I have explained just right now, they have mentioned it over here. You can read this inside your copy. This you will understand the thing that I am trying to convey. So this should also self-explanatory. The next part is the declaration of the my application. So actually there is in previous versions there was a my application. Now there is a tutorials app. So let me just close these unnecessary files and let's open this tutorials app, this and this to both files. So actually what they have did, they have created a custom application that we have seen previous video, that how we can create the custom applications. So the purpose of creating a custom application is to ensure that whenever we hook the trace sources to connect for the congestion window, so the congestion window is actually the property of socket, and socket is created dynamically during the runtime. So after the socket is created, then and only then you can attach the congestion window trace source, right? Before that, if you try to connect the congestion window trace source, it will give you some error. So this tutorials app, what they have did, you can go over here. This is start application method. So this is the by default method for any application, and as they have what we can say, created the tutorials application. So they have also created the start application method. So inside this, if you will see that they have bind the socket, and after binding they have connected, if you can see, and then they have called the method send packet. So what this tutorials app is trying to convey, or what is the thing that you need to learn from this tutorials app, it is the way that it is trying to hook the trace sources after the what we can say, the socket has been created, because the congestion window is a property of the socket. You need to just remember this, that the congestion window is the property of the socket, and sockets are created dynamically during the runtime, so we cannot hook the trace before it has been created. So to achieve this, the tutorials app what we can say, the application has been created. This is the header file for that. So if you will now look at the fifth.cc file, you will find the function that will track the old congestion window and the new congestion window. You will find this algorithm. I have actually modified this file. So actually let's see this fifth copy file. It should be the original one. Yeah, this is the original one. So you can see they have configured TCP new Reno algorithm. Then they have set at the initial congestion window to 1, and then there is a recovery protocol, but this is not important right now. And then they have created a point-to-point topology. You are now familiar with this. Now there is this line 115 to 117. So actually NS3 is built on some pre-modules, and the modules doesn't contain the real life errors. So to introduce the real life error, they have created this what you can say, error module that will that basically will, what we can say, populate or generate or simulate some kind of errors. So this is error module. So basically you don't need to what we can say, deep dive into what is rate error module, because that will be more time consuming. So just now assume that these 3 lines are giving some actual real life simulation of errors that can occur inside your point-to-point channel. This is error rate and something, but right now you just ignore 3 lines, but be sure to know about this, that what is this rate error model. Now this is internet stack, this is address assigning, this is server configuration, okay, this is TCP server, this is what you can say, the client configuration. And as you can see, they are connecting the trace sources. First of all, they are creating the socket, and which is the method inside this CC file. Now where is this create socket? Okay, so the create socket is actually the function for that application class. So as they have inherited the class, so there is this predefined method that is available. So the socket, inside the socket, they have created the socket, they have passed node, they have passed the type of the socket that they want, and now they are connecting on this socket the trace source, which is congestion window, and they are passing the reference to the function, which is CWND change that we have seen over here, right? And then there is this tutorials app that we have seen just right now, and then what they have said, this is another trace when the packet is being dropped. So this is not important right now. You can actually comment out this thing. We just need to focus on this trace, and you can actually you can obviously what you can say, explore this, that this is just physical RX drop, means the receiver side when the packet is being dropped, then this function will call and it will log that the packet is being dropped at particular second. So now they have simulated it for the 20 seconds, and then they have stopped the simulation. So this is the thing. So mainly what you need to understand over here is that what is the importance of this trace source that we have attached over here, congestion window. So actually there are some trace sources like congestion window that are attached to some object that is created dynamically. So you need to make sure that once the object is being created, then and only then you are attaching the trace source. So there is nothing more in that.
So I guess that's it for today's video, because the video is getting very lengthy and we shall keep the thing till here. We have discussed the thing, we have understood the fifth.cc file. Now in the next video we'll explore the how to generate the TCP variants. So basically we just now need to run that file, and I need to explain you the steps to generate the graphs and explore the graphs for the various TCP algorithms. So basically they are known as various TCP variants. So we'll see all those stuff in the next video. So for today, let's keep it over here. We'll meet in the next video. Till then, keep learning and keep exploring.